Hi guys, welcome to Unit 6, Lesson 4, Solving Equations Using Substitution. So far we've looked at a lot of graphs and stuff for solving systems of equations, but now it's well, what if you're not given a graph, okay? So I figured the best thing for us to do would be go straight into examples, okay? And so that's what we're going to do. Alright, so for number 1, this is also number 1 on your practice. It says solve the system of equations. Alright, so with this particular example, we are, with one of them, this first one here, it tells us what x is equal to. It says x is equal to 6y minus 3. So, with that, using substitutions, what I can do is I can actually plug this value in to this one over here to figure out, well, what is y equal to? Okay? So, by doing that, here's what I'm going to do. So, this says x is equal to 6y minus 3. If I plug that in over here, I can say 2 times 6y minus 3. All I did was I replaced x with this value here, plus 7y equals 13. Now the nice thing about that is now I only have one variable, okay? And I can solve down to one number, or hopefully one number, for y, okay? And then, using the y value, I can plug that back into the other one and solve for x. So, with that, here's what I'm going to do. I need to take care of my parentheses. I have this 2 hanging out here. I'm going to distribute that into my parentheses. 2 times 6 is 12, so we have 12y. 2 times negative 3 is negative 6, and then we have plus 7y equals 13. Now I'm going to combine like terms. So I've got 12y plus 7y. Well, when I add those together, let's see, I get, and I want to make sure I wrote it down right. Yeah, that looks good. Okay, so with that, let's see here. We've got, what did I say? 12y plus 7y. That gives me 19y minus 6 equals 13. Okay, well, now I'm just down to a two-step equation. That's awesome. So I'm going to add 6 to both sides. I'm left with 19y equals 19. Divide both sides by 19, and so y equals 1. All right, love that. That 19 is what threw me off and made me think maybe I wrote it wrong. But so this tells me that y is equal to 1. Now that I know that, I can come back here and I can plug that in for y in my other equation and solve for x. So that's what I'm going to do. I'm going to say x is equal to 6 times 1 minus 3. Well, 6 times 1 is 6, minus 3, x is equal to 3. So for the solution to this system, it would be the coordinate pair of 3, 1. And that's it. So I kind of like this method because it makes me feel like I'm solving like a little riddle, you know? So hopefully you feel the same. With this next one, this is number 5 on your practice. Says how many solutions does the system of equations have? And then we have 6x plus 2y equals negative 18, and 3x plus y equals 24. I'm just looking at my other screen to make sure I wrote everything down right. I've made some mistakes today and I don't want to mess you guys up. Okay, so, well, first off, I need to try to solve them, okay? I need to try to solve them to figure out where we are at. Now, both of them, neither one of them tells me what, one variable is equal to. But one thing I notice is that on this one, my y is by itself. So I could subtract 3x from both sides, and that would leave y by itself on the left. So y equals, and I'm going to say negative 3x plus 24. So this would be the other thing that we could do, is we could turn them both into slope-intercept form. But today we're focused on substitutions, so that's what I'm going to do. Now that I know what y is equal to, I know that y is equal to negative 3x plus 24, I can take this value and plug it in over here and then solve, so put it in right here, sorry, and then solve for x, okay? So with that, I'm going to do that now. Let's see, we've got 6x plus, and then 2 times, and I'm going to plug this whole thing in, negative 3x plus 24 equals negative 18. Yeah, and it is supposed to be negative. Okay, I'm going to distribute that 2 inside my parentheses. So let's see, I'll rewrite this, 6x plus, and now I have 2 times negative 3x. Well, that gives me negative 6x, and then positive 2 times 24 gives me positive 48 equals negative 18. Whenever you have an addition and a negative symbol right next to each other, it means like the negative overrides, or it means to subtract. So we've got 6x minus 6x plus 48 equals negative 18. Well, negative 6x minus 6x equals 0. So really this simplifies, those cancel. This simplifies to 48 equals negative 18. Well, that's never true. 48 never equals negative 18. So because I could not get it down to one solution, that tells me that there is no solution. Okay? If I was able to mimic this process, then we could have had one particular solution. Okay? If it had gotten down to the exact same thing, then there would have been an infinite number of solutions. This next one that we're going to look at is number 1 on your quick check. It says solve the system of 2 equations using substitution. So, same process. But this one tells me what y is equal to. I love that, right? Because now I can take this value, 2 plus 3x, and I can plug that in for y over here, solve, and then plug the next value back in here. So that's what I'm going to do. I've got 4x minus 3 times 2 plus 3x equals negative 16. Okay? I'm going to distribute my negative 3. So let's see, I have 4x. Negative 3 times 2 is negative 6. And then negative 3 times positive 3 is, I wrote the wrong thing, negative 9x, and then equals negative 16. Well, let's see, I've got 4x minus 9x. That gives me negative 5x minus 6 equals negative 16. Okay? And then I'm going to add 6 to both sides. Those will cancel on the left. I have negative 5x equals negative 10. Divide both sides by negative 5. They'll cancel on the left. I have x equals positive 2. All right, so now that we know what x is equal to, we can go ahead and plug that back in over here. And we can say y equals 2 plus 3 times 2, right? I just took this value, plugged it in for x. So y equals 2 plus 6. 3 times 2 is 6. So y equals 8. So most of the time they're going to ask for a coordinate pair. Well, my x value is 2, my y value is 8, and so that would be the solution to this system of equations. All right, hang in there. If you need extra support, let me know, and have an awesome day.